guys, everyone. So this is Jaume, and today I want to talk about self-hostable key management. This works for EVM chains, Solana chains, and other, just any other curve that you'd want to implement. And my desired outcome for the talk is that you learn that in browsers and in applications, hosting your own key management infrastructure comes with different trade-offs. And if you will see us with OpenSigner, we've tried to make one abstraction that works for both. So yeah. So as it is right now, I'm sure you're all aware, with key management infrastructure, you either make it custodial to begin with. It has a super strong lock-in, so once you choose one of the vendors, you basically never change because they host the keys of your users, and you're locked usually per life of your project. And of course, you have to trust that the security boundaries and implementations of your vendor are strong. So that's why we decided to create OpenSigner. It's an open source, MIT licensed, self-hostable key management. The key advantage that it has is that you can audit, and it comes with a security boundary that works both for browsers and applications. Another key part of OpenSigner is that it doesn't lock you in with one specific authentication provider. And that is really, really important because, well, as I'm sure you all know, many vendors usually lock you in with one. First you do the authentication, and then you do the key management. So one user is one key in their database. In OpenSigner, you bring your own authentication provider. And as we've seen in some hacks, for instance, the Contigo app hack, the authentication token that is issued from the auth provider, if it's not treated carefully, can become a backdoor into recovering the keys of your users. So OpenSigner, as I will explain, takes care of that edge case. These are the main properties of OpenSigner. The most important here, as I already mentioned, self-hostable, is that it's based on Shamir secret sharing. So it takes a private key, doesn't really matter the kind of curve that this private key was derived from, and it splits it in 3 different shares, and each of the shares is exposed in a specific security boundary, and the whole key is reconstructed only in one place once you use it, and then it's flashed. I will go over this in more detail now. So in order to sign a specific message, you must reconstruct the key. So as I mentioned, the private key is always split in 3 different shares, and it needs a quorum of 2 in order to be reconstructed. An important property here is that 2 different derivations of the same key cannot be combined. So every time that you do a new split of the private key, you get a new set of shares that cannot be used in previous derivations of the shares. So these are the 3 shares that we have with OpenSigner. There is the device share. This is the one that lives and can be stored in the local storage or whatever permanent storage that you have in the user's device. It can be deleted, and that doesn't incur in a loss of the private key of the user. Then you have the hot share. This share is used in combination. I will go over this in the next slide, but just for you to have like an overall idea. Hot share is fetched every time the user needs to use this their wallet, and the cold share is only used when the user logs in into a new device to derive a new set of shares for their wallet. So this is the whole flow. I will go over it from your right side to the left. So I just presented that you have the 3 different shares. You have the cash which is the device share, then you have the hot share and the cold share. So for a completely new user, what you do is that you spin out a security boundary that is limited by an iframe that is locked to a specific domain that you trust. So in this specific iframe that you trust, you generate this new private key and you split it in 3 different shares. Then you take 2 of these shares and one you send it into the cold storage and the other one you send it into the hot storage. One key insight here is that, and I will explain this in the next slide, but you cannot simply just share what is the recovery share, the cold share, and send it onto the browser, because then you have to be careful on who controls the servers where each of the shares are stored. Because if it's the same entity controls the hot share and the cold share, they could, in theory, reconstruct your key, and then it's a custodial setup. So let me go over what are some of the methodologies that we created in order to secure the cold share, to make sure that the operator of this service can never reconstruct the full key without the user being in the loop, meaning that the user either has to provide some sort of entropy that they provide by a password or by using the PRF extension in passkeys, so to derive a key that encrypts the cold share, or another methodology that we created, which is what we call automatic recovery, which doesn't include any user input. So if you guys are interested, we can deep dive a bit more on that, but it's a bit more complex. So as I mentioned, there are 3 ways of encrypting the cold share that is stored in the recovery service. So you have the password, straightforward. The user gives you a password during the onboarding, and that password is used to encrypt this cold share, and this is only then used if the user needs to log into a new device. Once they are logged into a device, you only need the local share and the hot share. So you can combine those 2 to reconstruct the private key and use it every time. This is a key insight, right? Because you don't want a new user that comes into your application every time asking for what is the password and so on. So you only ask for it once per new device that gets logged in. Then the passkey, I will explain it just in a few seconds, but the key insight here is we use an extension called PRF to passkeys that allows for deriving a deterministic encryption key, and we use that to encrypt the recovery share. And the last method, the one that I mentioned is a bit more complex, is one that doesn't require any user intervention. And in this method, it only works in very specific scenario, which is when you have OpenSigner hosted by a provider, and this provider is offering this service to another app developer, and this app developer is offering the service to a user. So you see there a bit there's an extra step here, because this app developer has to basically host an encryption key, and this encryption key is the one that is used then to encrypt the recovery shares whenever the user wants to log into a new device. So you basically introduce a new party into what is required to create a wallet, but you get the improvement where the user doesn't need to recover a password or worry about losing the passkey because they deleted their Bitwarden account or any of those things. So this is what I mentioned just now about passkeys. In theory, it sounds awesome, and everyone should use it. Jack Dorsey is endorsing it for, to create a file sharing system where everything is encrypted in the cloud, and you can create, in theory, applications where the user only has a private key that they control, and then you can encrypt everything with it. In practice, we've seen it's a bit more complex. For one, because the UIs from most devices we use do not give the flexibility of changing what the UI says whenever you're using a passkey, so they think you're logging into something when you're actually doing something pretty important, which is decrypting and encrypting. And sometimes users do factory resets, and they don't know what they're deleting. They're deleting all their, some of the passkeys from their, password manager and so on, and then they lose the passkey, and then it's catastrophic, right? Because this is basically holding the encryption key that has access to their account. So we've seen that as well. So it's not jack of all trades. It has some advantages, but yeah. So this is the setup of how it looks like to host OpenSigner. So you have your application, which, as I mentioned, can be a browser, but we've made it work as well in mobile applications, React Native, Swift. It doesn't really matter. And then you basically spin out an iframe service. This iframe is the security boundary where the private key is generated, where the keys are split and the wallet is reconstructed every time. And so then the app communicates, so the app, let's say it's a website, communicates with the iframe service through a post messages, and then the iframe service, given that you can reconstruct the key, will respond with the signature. And inside the iframe service, you're communicating with the three key services here, which are the hot storage, where you only interact when you want to recover, cold storage, hot storage when you want to interact every time you want to sign, cold storage when you want to recover, and the auth service, which is another security boundary that you only expose any, the hot storage and cold storage whenever the user is authenticated. So you can bring your own auth service here, you can bring BetterAuth, you can bring Okta, Auth0, doesn't really matter. The only important thing here is that OpenSigner will have an endpoint that you will be able to configure, and then you basically will send it tokens and it will verify them and answer back with basically a Boolean yes, no. And then it will allow for doing the next action, which is returning the share. So this is a very quick comparison. It's super broad, like the rest. What does it really mean? There are so many options out there. But it can serve as a summary of all the things that we accomplish with OpenSigner. So most importantly, MIT licensed. You can self-host it. It's non-custodial. We are a bit picky here. We've seen some providers, like for instance, Privy in the beginning was mentioning they were self-custodial. Our opinion, only self-custodial when the user has the key. In this case, the key is split between multiple providers, so non-custodial. Auth provider, as we mentioned, totally agnostic. Chain support, it's only key management. It doesn't do anything else. So we have support for Solana and EVM chains, but you could, in theory, expand to some other as well. And signing speed, super important as well, because you only need to do a fetch of the hot storage once the user is authenticated. The only limiting factor is how fast can you get the hot share. So what is the ping speed between the iframe where the user is and where the server is, where you're hosting the hot shares. So this can be 100 milliseconds, could be less, could be more, depending on where you have your servers or if you are distributed or not. So the key thing, this is just like a summary thing on the whole steps, and that's basically it. As you guys can see, go check the GitHub repository. We have some documentation explaining more in depth what are some of the setups that are possible with it, and some pitfalls that we've seen, and how to add it into your system. So check it out if you're interested. And that's it from all talk. If you guys have any questions.
Okay, so does anyone have?
Yeah, thank you. I wanted to ask about the advantages of using the fiat Shamir secret sharing versus using a simple 2 out of 3 smart contract wallet setup? Like, what is the advantage for it? It seems like an extra hassle to manage all this crap. Like, I can just have the same thing.
Yeah. So we built OpenSigner, and we starting from the smart account perspective. So I co-founded Openfort, where we started only with smart accounts for EVM chains. So we started only with smart contract wallets, with hosting the bundler, creating the paymaster service, and giving everything bundled together to make it work. And what we quickly realized is, one, you still need the key management if you are not using passkeys directly in the wallet. And two, how do you make it multi-chain? When most of the providers that we see out there, at least with pure smart contract accounts, if you want to use it multi-chain, then it comes with a huge hassle because, well, to use it into a new chain, you need to deploy the wallet. It's counterfactual. What does that even mean? How do I import it into MetaMask if I want to leave your app? Huge amount of issues like those that you cannot really get away with pure smart contract accounts. What we saw with 7702 and the Pectra fork is that changed the game a bit. You can, smart contract wallets, you can kind of merge them with EOAs in their properties. You can now kind of import a smart contract wallet, let's say, into MetaMask. You can simply import the private key and use the wallet normally, and that's a huge win. But you still need the key. There's no escaping on the key part. And passkeys, well, usually they are per chain. And how do you sync this state? I mean, I've been, I think, since Bangkok. That was what, 2 years ago? 3 years ago, maybe. They were already speaking about synchronizing state between chains. Coinbase team was working on it. Some other teams were working on it. I haven't heard anything about it since 2 years. So how do you sync the state of what are the recovery guardians of a specific smart contract wallet? How do you sync the passkey wallet between different chains? In my opinion, those are still unresolved questions. So that's why you always get back to the key. And that's a gateway. From it, people create more complex applications, but the complex applications then always become gated at the end. So, yeah.
Yeah, I have a question. If we focus on the initial part when we are creating the private key, it's strictly created in the iframe, as you said.
Could you repeat the beginning of the question? If you focus
on creating the private key part, so you said it's created in the iframe, right? So if we consider the situation, your device is compromised, but you don't know about that. How can you trust? This. It sounds like there is this initial issue.
So the key properties that you get with iframes is that in modern browsers, there are isolated services from the hosting machine. So the key question here would be, what happens if the iframe is compromised? So the one that is hosting the iframe is compromised. Then you're cooked. The iframe is like the security boundary, and they basically are inside the security boundary. And so then it's really, really problematic. But for a hosting machine, if a user's browser is compromised, I guess, for instance, you could modify the UI of the user to trick them into clicking a specific part of the UI that does the reconstruction. That would be an issue, right? But the iframe and the host browser are isolated services. So in that sense, maybe there are some ways that I'm not aware, but there are faster ways. And so there will be faster ways on modifying the UI, for example, into signing something else, sending the message the wrong message. I mean, there are some other ways, right?
I know, but we also didn't know about the Spectre attack, and then it happened, right? And it would be the case that we consider it secure, but until it isn't, because we don't know about all its vulnerable it is. So there are also, usually we generate the private keys in servers where are isolated or separated in some external devices like signers and so on. So yeah, I just...
No, I mean, it's a good point, and so it's all about like for example, like if you believe that there will be an exploit that will break the security boundaries of browsers, that will make iframes exploitable, that iframes that are not hosted in your machine exploitable. I mean, maybe, but like I think like this is more like on speculation territory. I mean, I don't know if AI will be able to figure out like new attacks on this kind of stuff, but maybe there are also attacks on the server side of things. It's hard to say. I know like you get some advantages and you leave some. It's just like another proposal that you get, and here where everything would happen on device. So yeah, that's my answer.
So adding to that, like, right now the code is storing the device share into the iframe, right?
Yes.
So that's very insecure, and from an XSS point of view as well, right? Because the browser implementation of the local storage is tab-based or like domain-based.
Oh, well, I mean, here it said local storage, but like in production, you would not host it in local storage, right? So
Where would be the ideal place then?
So, for example, at Openfort, we run OpenSigner as a service, and so you would have, a domain from a third party hosting the iframe, and that would be loaded whenever you want to interact with your wallet. So it's an invisible iframe that is loaded in your browser, and then you communicate with this iframe through a post message and event listeners. So it's never like in local storage. Here it was set as in if you start OpenSigner locally today, that's how it would look like. But in production, you never serve stuff in local storage. Yeah.
But couldn't the malicious service worker be able to be installed to this domain, third-party domain, and there are vulnerabilities? I mean, the browser implementation of local storage varies from one provider to another. It varies from Firefox to, let's just say, Chrome. But again, there is always that vulnerability that extensions can listen to it, as well as service workers, primarily.
Right. So I think the key part here as well is that most of the vulnerabilities that you referred to would not be independent to, would be affect as well any, would affect differently if you had your wallet, for example, hosted in a server, because if you have a Chrome extension that is malicious, it can, for example, intercept your network messages with a backend, and then you can change the payload and change whatever you want. So the key thing here is that you're in local storage, even if your iframe is, your machine is compromised and they can get your local share. Local share alone is useless. And so the key is only fully reconstructed at use time. So whenever the user wants to sign something, the hot share is fetched, the key is reconstructed, is used, and then is flushed. So it only lives on the user's device by a very few milliseconds. So if your browser is compromised because you're doing something else in a different page, or you install a Chrome extension and you're not using your wallet, that doesn't affect anything. And even if they get the device share, by itself is not useful.
But all it takes for me is a single transaction. I just need to sign a single malicious transaction to extract all the funds out of the user's wallet. So still, even if I don't need access to the private key of the user or the complete key, I just need to execute a single transaction. That's possible if the device share is compromised.
No, so if the device share is compromised, and let's say you have a Chrome extension that can infiltrate and get in between your post message and event listener, it doesn't matter the setup that you have. So for example, if you are sending like a payload, just a payload into a backend server, the backend server signs the message and you get it back, you'll be compromised as well. So the issue here is like your server is, like your browser is compromised, not that you have like a local share, because this local share is isolated in the iframe, and you know, even like when you try to use it, it would have the same security guarantees as if you were trying to communicate with a backend service. So
Okay. So again, adding to that, since you talked about the AIP for 7702, right? So why not, if it's possible to delegate the entire contract, the address to a smart contract, wouldn't it be safer with coupling that contract to, let's just say, a passkey instead of this vulnerability, a potential vulnerability via storing local, like in the storage device share? Can we just bin the private key altogether?
So yeah, we've seen some approaches where you create an ephemeral private key, you do the delegation, and you completely forget the initial private key.
Yes.
And during this initial setup, you see, you set up a passkey, and then you use that as your wallet. That's
And it works against all chains too then. If you're able to
I mean,
obtain a request with chain ID,
yeah,
I guess, -1, then it works against all chains.
Yeah, you could in theory then take that initial transaction that you used in the origin chain and repeat it into all destination chains, and then you'd have the same setup. You will have though an issue in if you change the origin setup into a new passkey, that doesn't translate into the new chains. So you can have smart accounts that are out of sync between each other, and then it can get really complex. But yeah, I mean, it's another.
But you can always add more passkeys. That control can still be granted.
Yeah. So yeah, but like you have to keep the state synchronized manually. So there's no service that I know of that would keep the state synchronized between blockchains. So you change the passkey in one chain, it doesn't automatically change in all the other chains where you have your wallet deployed. So you have to go like in all the other chains and basically deploy it as well. Same for guardians if you have some, or any other ZK email, doesn't matter.
Yeah, but we always have the transaction. That transaction, the request is public. So if it's the chain ID -1, anyone could actually relay it. Even you could execute that transaction of my account. Like you added a passkey, but it's getting added to all accounts. So anyone unauthorized can actually sync the transaction. A relayer, a simple relayer would do.
I think for the initial chain, like for the initial setup, that's possible because doing the delegation, you're putting chain ID 0, so it applies to all the chains. For subsequent transactions,
you can still have chain ID 0 there too. What's the problem with that?
If you do a normal transaction, you don't have chain ID 0, right? It's a regular transaction, and chain ID is not 0.
No, it depends on how you write the smart contract to actually accept a passkey hash. Yeah.
I guess then. Yeah, I mean, I
yeah,
guess
you could verify.
I think you can have problems then with nonce, for example. I think like there's an edge, like a sea of edge cases where then you need to have like, what if the origin transaction has nonce 1 and another chain has
yeah,
nonce 20?
Should be synchronized. Nonce.
You see, like there's like an edge of like 20 edge cases that actual products and users would never
Yeah,
have.
ideally, Proto. Have you heard of Proto.sh? They actually figured it out. Like they maintain separate nonce for these kind of changes, like a master nonce.
Yeah, you
then
have
the
like
problem
kind of
is solved.
nonce and so on.
Yeah. Thank you.
So any other questions? No?
Awesome.
Okay.
Thanks.
Thank you. So that was the last session for today. We hope to see you tomorrow as well. Thank you.